Okay, we're starting in a new book right now. Book L it is. It's the last book that we would do, and it kind of goes along with Book K. It kind of just an extension of that. And some of the stuff that we're going to talk about, especially in this section, is a little bit on this stuff we've done before, but it kind of goes in with what the section is about, so I'm going to kind of repeat the stuff. And also, I cannot post any of the readings for this section or this book online because it's an old book. So I sent it all home with you. Hopefully you picked up stuff the March pickup time. And if you did, you have the book, which means then you have the reading material for these sections as well. So this first section is on describing chemical reactions and different ways to describe them. So elements represented by one or two letter symbol. We know that. So something like Fe for iron, H for hydrogen, O for oxygen, C for carbon, things like that. So every single element has that. And when we start writing chemical equations, we're going to see those 1 and 2 letter symbols come into play because it makes things a lot easier to write a chemical equation if you don't have to write out every single word. And then a compound is represented by a chemical formula, something like H2O, CO2, C6H12O6. Those are some common compounds that you will see, and then those are what they call chemical formulas that talk about that. A subscript is written down below a number. Superscript is written up above. It's kind of just off to the side. If you talk about like x squared or 2 squared, that's a superscript. When you see C6H12O6, the 6, the 12, the 6 are all written down below and to the right of the chemical symbol, which means that's what we call subscript. And this shows the number of atoms of an element in a compound. So if I have CO2, that means there's 2 oxygen and 1 carbon. If they don't write a 1, that just means there's 1 in there. It's an implied 1. So like H2O, 2 hydrogen, 1 oxygen. And that's basically how those types of things go. Okay, so on a chemical equation, the left side of the chemical equation is what we call the reactant side, and the right side is the product side. So the left side will show your reactants. What goes into the chemical reaction? What are the things that are reacting with each other to produce something? Which means the thing on the right side is the product. It's produced from when you react two substances together, or when you put a substance to, when you have a known substance and you break it apart. Or if you basically put 2 different substances together and we kind of like move things around and we have new products. A chemical equation, like I said, uses symbols to show reactants and products of chemical reactions. So when we have something like this, we start over here. This is calcium carbonate, basically. So calcium is Ca, carbon C, oxygen O. Now there's no equal sign because even though they are equal on both sides, but something's happening in a chemical equation or a chemical reaction. So it's yielding, it's producing, it's creating something. And so that's why we call it yielding instead of an equal sign. That's why you'll see an arrow there. And so here are my products. CaO, so calcium oxide, and then CO2, carbon dioxide. And again, we're using symbols. So Ca, calcium, O, oxygen, C, carbon, O, oxygen. So each time you start over with a new capital letter, we have a new symbol created. And then formulas, we're putting the whole thing together. So CaO. Okay, and so it's just all those things I was talking about. So the subscript, again, is down here. This is what we call chemical formula. And then symbols, obviously, I talked about on the last slide as well. Okay, so conservation of mass. When we deal with chemical reactions, we know, or we should know, or we're going to know now, that whatever we have on one side of the equation, we have to have on the other. We don't lose mass. If we react something together, even if it ends up something completely different, it looks different, it might be lighter than the original substances that you put into it, it's still all there. It might not all be contained in the product. Maybe some of it was let off as a gas during the reaction or something like that. But all of that stuff is not lost somewhere. So, for instance, we're showing you here, and it's kind of hard probably for you to see, but we have 14 grams of iron and 8 grams of sulfur. When I put these together, 14 plus 8 gives me 22. So when I put them together, that's yielding. We're heating them up. That's why they're able to go together, heat them up, and they get iron sulfide, which is 22. They have the same mass on both sides of the equation. So conservation mass basically says the total amount of matter does not change during a chemical reaction. You have the same stuff on the product side as you do on the reactant side. So products and reactants have the same mass. Okay, this is where the real fun starts when we start talking about balancing chemical equations. So conservation of mass works for balancing chemical equations because you must have the same atoms on both sides of the equation. Sometimes they change places, sometimes they come together, sometimes they break apart, maybe things move around a little bit, but you have the same atoms on both sides regardless of what happens, because conservation of mass says we have to. We can't lose anything. We can't gain anything. It just stays the same. It just moves around. So to balance chemical equation, we use these things called coefficients. Coefficients are the numbers in front of the chemical formula. These things down here, this 2, this 2, this 2, those are all we call subscripts. If I was to put a number in front of the H, or a number in front of the O, or a number in front of the H2O, that's what we call a coefficient. Coefficient tells you how many molecules or atoms and reactants and products. So if I were to put a 2 in front of this H, I would have 2 molecules of hydrogen. If I put 2 here, it would be 2 molecules of oxygen. If I put a 2 here, it would be 2 molecules of water. Now, notice that there's 2 atoms in hydrogen. We call that a diatomic molecule, which means they always hang out together. So if I'd ask you, well, how many atoms of hydrogen do I have if I put a 2 in front of this? That'd be 4, because I have 2 of the H2s. They hang out together. So there's an H2 and another H2, which means there's totally 4 atoms of hydrogen. Okay, so let's look how we balance the equation of water. It's kind of interesting, because if you look at it right here, if I was going to say that this is balanced, I can't, because I have 2 hydrogen atoms, 2 hydrogen atoms. But here I have 2 oxygen atoms to begin with, and here I only have 1, which means I lost an oxygen atom, which we know we can't do. So this next slide is going to deal with how do we balance a chemical equation. Okay, so I like to use water because it's an easy one to balance, and it makes somewhat sense, hopefully, when you look at it. So we start with the reactants and products that we saw on the other side. So we have 2 molecules of hydrogen, 2 molecules of oxygen, and we yield 1 molecule of water. Okay, this is unbalanced as we show here, and it's actually showing this picture form here. So we have 2 and 2, and then the red ones we have 2 and 1, which means we have more on this side than we do on the other. What happened? Something happened. We need to balance it out. Okay, so I usually start, what I do is I create a tally. So over here I would write 2, like I'd write an H and I'd put 2 next to it. I'd write an O and I'd write 2 next to it. On the other side I'd write an O and put 1, an H and I'd write 2. And I'd see right there that I have to do something. Well, right away I'm like, okay, well I could put a 2 in front of this water molecule here, and that will create 2 oxygen. And that's what I need. So now I have 2 oxygen atoms. But look at this. If I put 2 in front of this, 2 times 2 gives me 4 hydrogen atoms, which means now I have more on the other side. I'm going to have to do something on this side to balance it out. Well, this last one here shows how I do that. I put a 2 in front of the H2, which means now I have 4. So 4 are 2 molecules of hydrogen plus 1 molecule of oxygen gives me 2 molecules of water. And every single time water is created, that's exactly what happens. 2 molecules of hydrogen, 1 molecule of oxygen, and you get 2 molecules of water. And so now it's balanced. You can see there's the same on both sides, and that's what we need to do. Now, it's not that we're doing anything. We're not creating matter or getting rid of matter. What we're doing is we're showing how this actually works. That's what a chemical equation is all about. I'm showing you how it works. Or if I'm given information, I'm showing how it works. So it's just basically using the knowledge that I have from both sides and figuring out a way that it actually balances, so I know this is what happens during this chemical reaction. Okay, so 3 different types of chemical reactions, 3 basic types of chemical reactions. I'm sure you'll get into more bigger stuff as you get into high school and college chemistry, but we're just going to start with the basics. So synthesis reactions, I'm putting 2 or more substances together to make a complex substance. So we're showing down here that I've got all these pieces that I'm going to make for origami, and I'm putting them together and I'm creating a swan. Okay, that's putting things together. I'm synthesizing. If I'm decomping, decomposition means I'm breaking it apart. So I have my little cat here, and I'm breaking it apart into different substances. I'm breaking it down. And then replacement means that I start with something and I put it together and I rearrange things. So for instance, here's where I have single replacement here. So I have all I'm doing is replacing the diamond replacing the triangle with the diamond, and then the diamond's off by itself. If I have a double replacement, it means all sorts of things take place here. So the diamond and the triangle basically switch places is what happens. So then replacing both of them. They're basically switching places. So we call it a replacement. So they trade places within the reaction. Alright, so this is your first section. We're only doing section 2. We're doing another section as well, but we're doing section 2 here. Your worksheet deals a little bit with balanced equations. And I tried, if you picked up the packet from school, I tried to make it as easy as possible for you to balance those chemical equations. In fact, I even showed you how it worked. And then I want you to figure out what type of reaction it is. I'm probably going to send home a little bit or put some stuff up for like maybe extra credit or something so you can practice balancing chemical equations because it's kind of fun. Normally in class we'd spend a whole day, a whole class period going over balancing chemical equations. So you have a worksheet on this part. You can find it on PowerSchool Learning or in the packet if you picked it up at school or are picking it up, I should say, depending on when you get this. Or you can basically do it on a piece of paper, take a picture, and send it to me as well. All right, enjoy!